So let's talk about generative AI. Just before we go into Amazon Bedrock, which is a service for Gen AI on AWS, but I first want to take a step back and just understand what is Gen AI. So generative AI or Gen AI is going to be a subset of deep learning, which is a subset of machine learning, which is a subset of AI. So Gen AI, as the name indicates, is used to generate new data that is going to be similar to the data it was trained on. So what type of data can we train a Gen AI with? Well, we can train it on text, on images, on audio, on code, and video, and a lot more, whatever you think of really. So the generative AI model is going to take a lot of trained data. Here's an example where we are going to give it a lot of dogs images. So we have our trained data set, which are going to be dogs, but also we're going to feed them cartoons. So we're going to have a bunch of different cartoons that are going to be hand-drawn. And the generative model is going to see so many of these trained data that is going to understand what is a dog, what is a cartoon. And then if we ask it, can you generate a cartoon dog? It's going to be smart enough to combine the two together and create a dog that looks like a cartoon. And that is the whole power of generative AI, is that it's able to combine its knowledge into new and unique ways. So we're going to start with a lot of unlabeled data, and we'll see what that means in a later section. And we're going to train what's called a foundation model. And foundation model are very broad, they're very big, very wide, and they can adapt to different kind of general tasks. For example, a good foundation model can generate some text, can summarize some text, can extract information, can generate images, can become a chatbot, and can answer any types of questions you have. So as a whole, we feed a lot of data into a foundational model, which has the option to do a lot of different tasks. So now let's talk about foundation models. So in order to generate data, as we said, we need to have a foundation model, and they're trained on a variety of inputs. But to let you know how big these models are, usually to train a foundation model, a good one, it may cost tens of millions of dollars to train because it is very computational heavy. It takes a lot of time to train it and a lot of data. So only a few big companies usually are creating their own foundation model. So here is an example. So we have GPT-4o. That is the name of the foundation model behind ChatGPT, which is the application where you can chat with an AI. But there is a wide selection of foundation models from different companies. So we have OpenAI, this is the company behind ChatGPT and GPT-4o, for example. We have Meta, so this is the new company behind Facebook. We have Amazon, Google, and Anthropic, and of course, a lot more. But these companies are pretty big, or they have a lot of money to invest into building these foundation models. So some of these models are going to be open source. For example, they're going to be free. For example, Meta is working a lot on open source models. We have Google BERT as well, which was one of the first models in the Gen AI space, which also is open source. But some are under a commercial license. For example, OpenAI, you have to pay to use GPT at a certain level, Anthropic, and so on. And so we're going to see how we can access these models on AWS as well. So next, after the foundation model, we have the large language models, or LLM. So LLMs are a type of AI that is relying again on a foundation model, but designed to generate coherent human-like text. So you've been exposed to LLMs a lot before. One of these is ChatGPT, the GPT-4 type of foundation model, an LLM from the company OpenAI. So I went to ChatGPT and I asked it, are you an LLM? And it replied, yes, I am a large language model developed by OpenAI. And I can understand and generate human-like text based on the input I receive. So this was text that looks like a human wrote it, that was answered by ChatGPT when I asked it, are you an LLM? So the way LLM works is that they're trained on very large amount of text data. So they're usually very, very, very big models, very heavy, very computational heavy to use. We're talking about billions of parameters. They're trained on a lot of books, articles, websites data, or any other type of text data that is deemed good enough for the LLM training. So it can perform any wide range of language-related tasks, such as translation, summarization, question answering, content creation, and so on. So how does it work to use an LLM? So for this, we give it a prompt. So the prompt is a question, a bunch of text that you're going to send to the Gen AI model, the LLM. For example, what is AWS? That's the prompt. And we'll have a whole section in this course to understanding how to create a good prompt. Then the model is going to leverage all the existing content it has internally learned from, and then it's going to look at the prompt and answer it. And so when I asked ChatGPT, what is AWS? I get the answer. AWS is a comprehensive cloud computing platform provided by Amazon, and you can read the rest. It's a long answer. But you have to know something, and it's a term you have to learn, which is that the output, the generated text, is non-deterministic. That means that for every user that is using the same prompt, you will not necessarily, and usually not, get the same answer. So I went a second time and opened a new chat window and asked, what is AWS? And if you take some time to read this answer, this was again ChatGPT, you will see that while the answers are similar and they explain the same thing pretty much, they are not the same exact answers. And so this is why it's non-deterministic. So let's understand why, though, it is non-deterministic. So let's take a sentence that is going to be outputted by a LLM. And the sentence is, after the rain, the streets were. And what's going to happen is that the LLM is going to generate a list of potential words with probabilities. So what is the next word that is going to be probably here in this sentence? So the GenAI model is going to think and it's going to say, okay, maybe it's wet and there's a 0.4 out of 1 chance that is going to be wet, or flooded, 0.25, slippery, 0.15, empty, muddy, clean, blocked, and so on. So all these sentences make sense, but there are probabilities. That means that some of these words are more likely to be the next word in that sentence. And an algorithm is going to, of course, compute these probabilities, and another one is going to select a word from that list based on the probabilities. And for example, we're going to choose the word flooded. So it's going to be, after the rain, the streets were flooded. And this is all done by the Gen AI model. So now we have, after the rain, the streets were flooded, and the same process happens over and over again. So what is the next word? Well, it could be and, with, but, from, until, because, and even a dot. So after the rain, the streets were flooded, dot, and that's the end of the sentence. So all of these things, again, have associated probabilities, and then the next word is going to be selected based on these probabilities. So this is why when you ask the AI twice the same prompt, you may not get the same answer. It's because the sentence is determined thanks to statistical methods and not with deterministic methods. So that's for LLMs, but let's talk about images as well. So Gen AI for images works in a way that, for example, you can give it a prompt, for example, generate a blue sky with white clouds and the word hello written in the sky, and the Gen AI model is going to actually give you that image that, of course, we generated for this course. We can also have images generated from images. So here we give an image of someone playing piano, and we're saying transform this image in a Japanese anime style, and the outcome image is going to be something similar, but now it looks like it comes out of a manga. And then we can also generate text from images. So we give it a prompt and say, how many apples do you see in the picture? And we give it a picture with one orange and an apple. And then the Gen AI is going to look at the image and say, well, the picture shows one apple and the other fruit is an orange. So just to tell you how that works for Gen AI for images, so you get an idea of how something can generate an image. There's different methods, of course, but one of the popular ones nowadays is the diffusion model from a company, for example, named Stable Diffusion, which is using that model heavily. So let's take a picture, and this is a picture of a cat. And we're going to do what's called a forward diffusion process. That means that we're going to add some noise to the image over time. So this is with a little bit of noise, but it's the same image with a bit of noise. And then we add more noise. We can barely recognize the cat. And then we add more noise, and it looks like the cat is entirely gone. And all we get is noise. And so we do this for a lot of pictures. And this is called forward diffusion process. And once the algorithm is trained to take images and create noise out of it, we do the opposite. So when we want to generate an image, we're going to start with noise, and we're also going to give it a prompt and say, we want a cat with a computer. And it's called reverse diffusion. So now that the algorithm has seen how to go from an image to noise, it will go from noise to image. So we give it some noise randomly, and then it says, okay, I'm going to denoise it, and it's going to start to look like a cat. And then denoise it again, and then denoise it again, and then we have the cat with a computer. So imagine this is a new image generated by the AI and not the exact same it was trained on, of course. So this is how Gen AI works for text, for images. Just remember the concept of an LLM. Remember the concept that it's non-deterministic. But now you have a general overview of Gen AI, and I hope you liked it. And I will see you in the next lecture.